Hey everyone, welcome to our webinar today on gas system leaks. I'm Joe Wachunas here as always with my teammate Brian Stewart. We'll introduce our really great panel today to help us dive into this big problem of gas leaks. But we want to welcome you all to today's webinar. If folks want to put into the chat where they are calling in from or listening in from, we always appreciate that. We are Electrify Now. We are an all-volunteer organization that believes that electrification is the quickest and most cost-efficient way to decarbonization. We boil our message into 4 easy steps. Number 1, clean up your electric supplies through solar on your roof or subscribing to community solar or your utilities clean energy program. Number 2 is electrify your home. We have lots of videos on our YouTube page to tell you how to electrify every system on your home that uses fossil fuels. And then, of course, we've got electrify our transportation, the electric cars or electric bikes. And number 4, we want to bring everyone along on this electrification journey. There's so many benefits to electrification. And we are program Seeds for the Soul. We've been raising funds for this all year. Thanks to those of you who have donated. We'll put a link in the chat. They do programs for low-income households on solar and other electrification technologies. So thanks a lot for donating. Okay, so Brian, talk to us about gas system leaks.
All right, so I think all of us have been hearing some of the news about this in terms of the leaks that we know about, and it seems like we're learning more about this all the time. But I think if you just even think about this from a common sense standpoint, and you think about the system that delivers gas to our home from the wellheads, where this high pressure gas is pumped into these pipelines that then can cross interstate lines and go for many, many miles. And then of course they come into our cities and our towns with pipes underground. And then of course that then leads to gas meters near our homes and eventually into the appliances that are inside our homes. So if you think about it for a minute, this is like literally millions of connections of pipes from one place to another. Some of these pipes are very old and have been in the ground for a very long time. And so it sort of seems to logically make sense that we might be seeing some leaks along the way. And we've heard from in some of our past webinars, you might have remember that we did a session about gas stoves and how those leak even when we're not using them inside our homes. So we definitely have more and more information about this all the time. And the questions that we're going to try to be helping to answer today is, what do we know about the data, about the extent of these leaks? And what are the risks to local communities and individuals from those leaks? Who is accountable for tracking these leaks and fixing these leaks? And then how does this leakage problem affect energy burdened communities and the whole concept of equity, which is so important with our energy systems? And then what are the alternatives to the expensive patching that could be and most likely will be required for this leaky system? So those are some of the questions we hope to be answered, and of course others, but I'm really excited about our panelists today, and we'll be starting with Dr. Mary Finley Brooke, Professor of Geography, Environmental Studies at the University of Richmond. Her studies and her research focuses on justice in energy transition, and she's just co-authored a textbook which is about to be released called Climate Crisis, Energy Violence, Mapping Fossil Energy's Enduring Grasp on Our Precarious Future. So we're excited to have her lead us off today. And then she'll be handing off to Lee Williams, who is one of the founders of Beyond Methane RVA. She's a retired nurse. She was a founding member of this organization and is the acting director of Green New Deal Virginia, and also serves as a Sierra Club Falls of the James Group Advocacy Chair. And she's been one of the people doing a lot of the work in the Richmond area that we'll be hearing about. Dr. Nathan Phillips is professor of Earth and Environment at Boston University and has done a lot of research on this whole concept of the exchanges of energy, water, and greenhouse gases within our natural ecosystems and also human-dominated environments like buildings and pipelines, and has done a lot of research in the Boston area on the gas leaks question, which he'll be talking about. McKenna Dunbar from Sierra Club is Virginia's building electrification lead and advocates for initiatives that prioritize frontline rural communities, green workforce development, and net zero building policies. So she'll be talking to us specifically about this impact on the most vulnerable vulnerable communities and why it's important that we're considering that. And then we'll be finishing with Kevin Cianfarini from Electrify RVA and Beyond Methane RVA. He's an engineer from Virginia Tech and is now a renewable energy utility professional working on electricity demand response and virtual power plants, and will be talking to us about some of the financial issues that are associated with this leakage issue that are important for us to get our brains around. So with all of that, and I'm excited to turn the presentation over to Dr. Finley Brooks, and please take it away. Thank you.
Excellent. Thank you so much. Good afternoon. I'm excited for a fantastic webinar here. I'm Mary Finley Brooke from the University of Richmond, and I teach geography, so it's fitting that I start with a map. This is made by my collaborator, Stephen Metz, who you just heard about on the book that we're writing. He's from the New School, and this is showing thousands of gas lines in the US. These are largely meant to be out of sight and out of mind. And one of our main points today is that the gas industry has really eluded scrutiny to a great degree. If you go to the next slide, what we want to show is the whole system. So we have upstream, we have midstream, and we have downstream. Each portion has leaks of lost and unaccounted for methane gas. And really, quite shamefully, companies have gotten away largely with this expensive waste. We will talk about how it's often pushed on to consumers. But in the next slide, I point out it doesn't really matter if gasworks are publicly owned or investor owned. Those are usually your two types. And gas companies of both types have been granted what we call a natural monopoly status. And that means really they've been open to abuse of power in many instances that we'll be hearing about. Leaks are especially widespread in lines that are old and poorly maintained. These leaks, of course, drive climate change. We know that it's a potent greenhouse gas, methane, and they contain hazardous air pollutants that we'll be talking about, the harms to human health. But one of our biggest lessons that we would like you to take away today is that community action matters. I call us watchdogs, the people who are on this show today, and many others who have an oversight role. We add this necessary oversight, I'm calling it people power. And it's because of what's happening at the community level, many instances, that solutions do exist. We are finding ways, but we need to really start with education, because there is a lot of disinformation coming out of the industry. I'm going to talk about that a little bit. We need to have transparency and we need to have accountable oversight, again, because there are these abuses of power. Another important lesson from today is the need to connect electrification and the decommissioning of gas. This, of course, will consolidate. It'll save cost and effort. But a major lesson is we cannot promote electrification if the energy supply is fossil gas. Although this is quite popular in the US, it is just too dirty and too dangerous. The next slide reminds us that near the fracking well, or the well pad, is of course one of the areas of the greatest harm. If you have not had a chance to read the latest, the 9th compendium, this has just come out in October. It's hundreds of pages. It is the premier source on health harms. It covers the whole life cycle of gas. Of course, it does the best job of any publication showing risks to fracking, but it does show the whole life cycle. It has longitudinal and empirical studies. It shows severe risks. It's not that we've had a doubt, but this does have more than a decade's worth of documented harm, especially for vulnerable populations, such as infants, children, pregnant women, the elderly, and those with pre-existing illnesses like asthma and heart disease. Next slide. So leaks are probably more common than you know. And as I've mentioned, gas companies often have consumers paying for these losses. So it's watchdogs, again, I'm going to use that title, like Nathan Phillips, who made this map of methane leaks in the Boston area and has been a leading scholar on gas leaks for more than a decade. When somebody came on, they said they had the Nathan Phillips fan club. I'm in the Nathan Phillips fan club as well, and we are really fortunate to have him here with us today. His very effective research and advocacy is really a pathway for many communities to show how to get off of gas. And so we're learning from him here in Virginia. Next slide reminds us that the end of the pipeline is often your home. And so tracing gas from distribution lines in and near your residences is something that health professionals have been very involved in. Of course, we have a retired nurse with us today, Lee Williams, shown in the photograph on the right. She's from Beyond Methane RVA, and she's showing a volunteer how to use a handheld methane sniffer, which is one of the ways that we're able to show that these leaks are happening. This is inexpensive. A more expensive way, of course, there's infrared cameras and there are satellites with some remote sensing technology for methane plumes. Not everybody can afford these, but we're getting better satellites all the time. And so this disinformation is slowly being chipped away at. In the next slide, you will maybe remember that, does it actually go forward one more? I'm missing one here. Back, somehow I had a disinformation slide. Nope, there we go. And so you may remember that there was an oversight commission in the US Congress, and they reported in 2022 that gas companies are actively deceiving the public. This is some of the ways that this deception happens. And so the table mentions the inflated employment numbers that are often around gas construction projects. Many of us are aware that these are not factual. There's also the minimization of true costs. So people often pretend that it's a cheap energy. We're going to find out not only is it very expensive when you bring in the true cost, but that the costs of gas are going up and up. And the industry often downplays the risks of things such as fire and explosion. And you'll be hearing about that more. Next slide shows us that the impacts in the industry are often, and throughout the energy sector, are often disproportionate. And so we need to look at the full life cycle. And if we try to electrify, in the beginning, it was talking about our homes, our workplaces, and our rides and everywhere. If we're aiming to electrify and we have not gotten off fossil fuels, in fact, we could be causing unfair harm. And we find that this is often disproportionate. It is most harmful in many instances to people of color or low wealth neighborhoods. And this is symbolized here as sacrifice zones. And there's a huge literature on this. So if you go to the next slide, we want to point out that the cost of energy is geographic. It often does depend on what your zip code is, but then it also depends on many instances, your household. So energy burden hits those who are often struggling financially. It may be because of housing burden. It may be because of food insecurity. It may be the type of home and the condition or your own physical health. And so really thinking about what burden is put on people as we transition off of gas, and if we do it ineffectively. And I know Kevin will be talking about that later. So I'm going to go to my next slide and just point out that we really need to keep diversity, equity, inclusion, and justice, which we will be covering today, as essential throughout every step of the process. We really need to be doing better across the energy sector. Even when there are oversight boards, and we're going to be talking about a new board in Richmond, these may not be representative, and they may not be considering marginalized populations, and they may even be forwarding an industry agenda that could be at the expense of ratepayers. So in my final slide, I want to point out that it's an exciting day in Richmond, and we're going to be hearing this from Lee Williams, but we had a city council vote this past Monday to create a utility oversight commission. Honestly, this is where the work really begins. And I'm going to end here so you can hear directly from movers and shakers who are making decarbonization with equity a reality. We're using an economics-based strategy, and I will pass things over at this point. Thank you very much.
Outstanding. Thank you, Mary. If we could advance the slide, please. Excellent. So I'm basically the program manager of Beyond Methane RVA here, and I'm going to share a little bit of our origin story and also how you can duplicate our project where you live. So taking you back in 2019, a coalition of environmental, social, and economic justice groups got together under the umbrella of Green New Deal Virginia to support and advocate for a resolution before the Virginia General Assembly to declare a climate emergency. Our coalition included the Virginia chapters of the Sierra Club, Poor People's Campaign, and XR Rebellion, among many others. You can see it on the banner. This paper was in response to the IPCC IPCC report warning us that we had just 10 years to transition our economy and its workforce to renewable energy resources and to draw down our emissions. Our resolution passed the House, but was defeated when it crossed over to the Virginia Senate. We tried again in 2020, but for some political reasons, the resolution never made it out of the House of Delegates that year. Next slide, please. So in 2021, we thought we'd try something different and took our resolution to localities across the Commonwealth of Virginia. We just elected a new city council in the city of Richmond, and one of its freshman members, Catherine Jordan, not only patroned a climate and ecological emergency resolution, but made sure to include 13 initiatives within it so that we can build legislation on their foundation. The resolution included everything from electrification of city-owned fleets and buildings to phasing out reliance on gas and accelerating investments in city-owned renewable energy, plus granting collective bargaining capability to city employees so they would be protected from a phase out and have a just transition. Next slide, please. After the resolution passed, our locally based coalition of organizations created working groups to create budget recommendations and to shepherd each of these 13 initiatives across the finish line. Electrify RVA is where Beyond Methane RVA found a home. September 13th marked the second anniversary, second anniversary of the resolution. And I really want to pause here and applaud the commitment shown by the many volunteers, as well as the Richmond City Council, the staff members in the Office of Sustainability, and other essential and dedicated Richmond departments who have been pushing hard for a greener and more equitable Richmond these past 2 years. And thanks to them, we have some tremendous wins to celebrate. I'm not going to read them all, but and this past Monday, as Mary said, November 13th, we passed the Public Utility and Services Commission. Next slide, please. All right, so how did we get here? At the beginning of the COVID shutdown, I moved into a very different section of the city and began taking a new route to my favorite Saturday morning farmers market. Without fail, every time I rolled through this specific block, I would get hit in the face with the strong rotten egg smell of mercaptan. Around the same time, I started following another Sierra Club group up in DC. They were doing work as Beyond Methane DC with their local chapter of the XR Rebellion. And I thought we should form our own working group down here. So Dr. Mary and I have been friends and allies since our Atlantic Coast Pipeline fighting days, and with the help of the local Sierra Club Falls of the James Group family of rebel rousers, we hatched our plan. We applied for and received a grant from National Sierra Club, and on our very first test run with volunteers, students, and our new Sensit Gold methane detector, found a 100% low explosive limit, or LEL, at the intersection I'd been smelling gas at for 2 years. So after many FOIAs, we found out that the city knew of over 900 leaks in their service territory, and that it took them an average of 245 days to repair them. Once we started going out across the city and sniffing for leaking gas, we found 30 100% LELs just within the city limits alone, not even their entire territory. With the help of Mary and her colleague Beth Zazamia from the University of Richmond's Spatial Analysis Lab, we worked with student interns to create our ArcGIS map and raise public awareness by presenting to everyone who would have us, from city council members to civic associations to first responders at the Richmond Fire Department, Richmond 911, and the individual firehouses across the city. Next slide, please.
Lee, sorry to interrupt, but just to clarify for our audience here, that LEL terminology you're using, that low explosion limit. Can you explain a little bit more about that?
Yeah, sure. So the definition of that is it is the lowest amount of gas by volume needed to light or explode. So the danger with what we were finding is if it's just a small leak at a pipe and it's going directly into the atmosphere, you can light it like your pilot light of your stove. But if there's a big volume of space where that leak is and that gas is trapped under the pavement, the sidewalk, the street, and these leaks were in the middle of a very busy 4-lane street, if there was a big enough volume of gas, it could explode.
Thank you. Yeah.
Great. So what is a PUC? And why do we need one? So our Public Utility and Services Commission is fundamentally a good governance ordinance. As we've been doing this work for the last couple of years, we realized that nobody on City Council knew where the money was coming from, where it was going, and who was in charge over at the Department of Public Utilities or in their Richmond Gas Works. So We need this commission to enhance public awareness and increase transparency of the important and complex operations of our city-managed public utilities. A better informed public and city council will be better able to provide oversight of these basic city operations and help us reach our sustainability goals. The passage of the commission ordinance is the first step in phasing out reliance on gas and accelerating our investments in city-owned renewable energy as per the 2021 climate resolution. Also want to add, we are also including gas. Along with gas, we are including clean water, wastewater, stormwater, and oh, I lost another water. Anyway, it'll come to me later, but I'm out of time. Next slide, please. If you would like to learn more about us, just follow along on our socials, and I'm going to kick it up over to Nathan now. Thank you.
Thanks so much, Lee, and thank you, Joe and Brian, for having me, and fellow speakers. I'm in your fan club. I'm a natural scientist, and just learning from others about the political dimensions and the community science is really makes me feel more powerful with you. So let's jump in. We're going to talk about a lot of the data from the Boston area, but which also applies across many parts of the eastern seaboard, across the Boss-Wash corridor, and even below. So urban gas leaks, we're going to talk about problems and solutions. I don't know why these were, I'm responsible for having these gas leaks in green here in Boston in front of the State House of Boston, because they're definitely not green. So let's dive in. Next slide. Yeah, so just to back way up, we have a global problem with methane. It's clear that over the last, in the industrial age, the methane is rising even faster than carbon dioxide is rising relative to its pre-industrial level. Next slide. And it's happening just in these last few years. It's increasing higher and higher. Next slide. That's from NOAA, the most recent data. And this is the EPA's pie chart of where all the methane in our atmosphere is coming from. And you can see that the EPA estimates that the largest single chunk of methane is coming out of our natural gas and petroleum systems. There's also coal mining methane leaks over there. So fossil fuels is responsible for a lot of our methane problem. And I want to just say that the EPA is probably lowballing the estimates, because the most recent data from aircraft and satellites are finding results that are 60% higher than the EPA estimates from Ramon Alvarez and the folks at EDF back in 2018, or 2 times greater than estimates from EPA by Genevieve Plant and co-authors, or Weller's paper that shows 5 times higher estimates of leaks than the EPA. But it's even the EPA shows that we have a large problem with natural gas systems. Next slide. So I'm going to touch on 3 points very quickly. And first, we're going to start off with the scope of the urban gas leaks problem. Then we'll talk about the greenhouse gas impact and then solutions. So let's go to the scope of urban gas leaks. Next slide. Yeah, so Boston was the study that in 2013 we kind of touched off as the first study of its kind in cities, where we discovered over 3,000 gas leaks in the city of Boston. Next slide, advance please. And the story is similar. Washington, D.C., if anything, is leakier than Boston. This is a study that we did in 2014 led by Robert Jackson and others. Next forward, please. It's also the case in Durham, North Carolina, and in New York City that we have extensive gas leak problems. So these studies are mounting since early 2012, 2013. Next slide. Okay, so you've seen this. This is the picture of all the 750 road miles in Boston with the 3,356 gas leaks there, again, in a green color, which probably shouldn't be green. Next slide. And it's no mystery why this is the case. So here's the gas pipe, a little snippet of the gas pipeline network in Boston. And if you look in a little bit closely, my eyes are getting bad, but you can see ages of some of these pipelines here in the Back Bay region and the Beacon Hill that go back to the 1800s, the late 1800s. We still have these old leaking cast iron pipes under our streets and sidewalks. So it's really no wonder why they're leaking. It's an old system, and this is something that characterizes much of the eastern seaboard. Next slide. So let's talk, what does it all add up to? Let's talk about the greenhouse gas impact. Next slide. Okay, so here's a very, very complicated data sheet from the Energy Information Administration that shows basically we don't even know what we don't know. And this is all 50 states and DC that shows the lost and unaccounted for gas. That lost and unaccounted for gas is some combination of leaks, accounting errors, and meter errors. And it's a big black box. But if you look at that top green box, which I can't even see myself, we have situations in which the gas leaks are actually negative as a percent of the amount of gas that was delivered into a state. More comes out than apparently went in. And that is something that indicates we don't really have a good handle at all on what the leak rate is, what the accounting errors are, and what the meter errors are. Those couple of boxes down there show the size of the leaks can be large. 3% leak rate is considered to be as bad as coal for the climate. And a lot of these numbers, if you just scan up and down that last column there, are all over the map, from negative numbers to positive numbers. And one thing that just shows you how statistics can really conceal, as Mark Twain said, is if you add up a bunch of those negative values, which violate the conservation of mass, and you offset them with some of the positive numbers that are on there, you get a leak rate at the very bottom that looks not so bad, 1%. And so that's an indication of how the problem can appear to be not so bad when you put a lot of these offsetting errors together in here. So we have a lot of work to do to uncover really what is the leak rate across the different 50 states. Next slide. So what we did in the Boston area is go up high. We did a top-down using the integrating power of the atmosphere. We did a network on top of the Prudential building and other spots and put methane sniffers up on top of these buildings and measured what the buildup was of all of those gas leaks. Next slide. And we published in 2014 this paper. There's the areas there on the left with the natural gas consumption areas shaded in blue, our network of sites. We needed to know to the right there, well, methane might be coming out from cows and wetlands and landfills and also pipes. And this ratio here allowed us to fingerprint which portion of the gas that we were picking up at the tops of these buildings was from pipelines versus other sources. And that used a mass balance tracer, which is in that figure, of the ethane to methane ratio, because there's ethane in the fracked gas. There's no ethane coming out of wetlands or landfills. And that allowed us to do a mass balance tracer. And we found from this study back in 2014 about a 2.7% leak rate coming out of the urban eastern Massachusetts, basically, which puts it basically about as bad as coal. And that has nothing to do with the upstream leaks at all. That's ignoring all of the upstream leaks that Brian showed early in the talk. So a big problem here. Subsequently, in 8 years after this study, despite a lot of policy changes, the leaks are popping up as fast as we're fixing them. So that 2.7% has remained at about 2.5% over the last 8 years. That was published in 2022 by Sargent et al. Next slide. Okay, so let's pivot to some solutions very quickly. And one paper I want to really highlight, led by Margaret Hendrick, gave us a pathway forward, looking at how the methane leaks were distributed statistically. Is it like a bell-shaped curve? You have an average leak rate, some are higher, some are lower, and the answer was no. We found super emitters. Margaret led this study. Next slide. Margaret found, doing the hard work of being on the streets with things like this turtle shell sandbox lid over complex leak areas, to actually find how much was coming out of a subset of 100 of those leaks that you saw in that big spiky figure. Next slide. And found that a handful of the leaks accounted for a large amount. 7% of the leaks accounted for 50% of the loss. So that provided a policy way forward. If we can find and fix those super emitters, we can afford ourselves time and resources and money to actually transition off of gas. Next slide. We can also think like ecologists. I'm an ecologist, and think for opportunities and find opportunities lost. This is a new tree planted right into a gas leak. This tree is going to die. We can look for the opportunities to multi-solve in our urban areas. Next slide. And when we think like ecologists, we can start to see what's below the street. Where are our opportunities? This is David Macaulay's book, Underground, which is actually a street shot of Boston. If you peeled the road layer off and look down below, you'd see where the gas lines are. You'd see where the sewer pipes are, which might be thermal resources that we can tap into and move in a different direction than fracked gas. Next slide. So our conclusions here is that the scope, at least in Boston, we find over 3,000 leaks. Evidence is mounting this is a problem across the eastern seaboard. The problem differs in other parts of the country. The greenhouse impact, if you add it up to our greenhouse gas emissions inventory in Massachusetts, it was 10% of our entire greenhouse gas emissions inventory. That was not on any ledger before this research was done. Our solutions are to find and fix those super emitters, to give us the opportunity to do something different and cost effectively transition off of gas, and to really use that infrastructure, what we call infrastructure ecology, to look at our entire streetscape and our infrastructure to find out synergies and solutions. So with that, I'm going to pass it on over to McKenna. Thank you.
Good afternoon, everyone. Today, I will be talking about future forward strategies for integrating energy efficiency and building electrification as part of this gas leak crisis. Next slide, please. I will first start off with a quote by Jerome Foster, the youngest ever White House advisor for environmental justice, where he says, "Climate crisis and social injustice are inextricably linked. We demand not only action, but transparency and accountability from governments on existing commitments." And, this greatly needed urge for accountability and transparency is necessary due to the abuse of power inherent as part of the fossil fuel industry, a key topic that Dr. Finley Brook spoke about earlier. And so for that reason, I will first detail what is the topic of energy colonialism. And this topic refers to economic structures implemented by powerful entities to facilitate production that can continue to essentially promote economic activity in the long run. So continued use of fossil fuels that leads to big problems like the methane leaks we not only see in Richmond, Virginia, but in the many other locations that Nathan mentioned earlier. And so primarily these topics of energy colonialism can be detailed in 5 keywords. Energy colonialism is extractive all across the nations, anywhere, but particularly in the United States. Economic systems shaped by colonization really emphasize resource extraction, especially at the expense of indigenous and local communities. Energy colonialism causes displacement, and this is reflected in how indigenous and local communities are frequently relocated or disproportionately bear burdens to make way for energy projects, particularly fossil fuel projects, echoing colonial land seizing practices. energy colonialism leads to exploitation, where colonized regions have historically provided cheap labor and resources, and all of this perpetuates economic imbalances and dependencies as reflected in energy burdens. Energy colonialism causes dependency and also limits national security, as many of us know, because energy infrastructure is built typically by monopoly utility companies and other powerful entities. It really ensures continued reliance on fossil fuels, which then limits local growth and self-sufficiency by way of the clean energy transition. And ultimately, energy colonialism fuels the notion of consumerism. And beyond resource providers, colonized areas were molded into markets for industrialized economies, which perpetuates economic disparities as a whole and has one-sided benefits for many. Next slide, please. So the topic of energy colonialism and the prevalence of energy burdens, which Dr. Finley Brook alluded to earlier, in institutionally underserved communities are very closely linked concepts, both illuminating aspects of unequal power dynamics and lack of access to resources. Energy burden refers to the disproportionate impact of energy costs on certain communities. I'm not going to read the full thing, you can read it, but essentially this burden exacerbates poverty and limits opportunity for economic development. There are many calculators online where you can search the energy burden if you experience any in your community for how much you spend on your energy and utility bills in particular. And for many regions in the nation, especially in Virginia, energy burdens can reach 17.5% of a household's income, which reflects a big problem. And both concepts are rooted in systemic inequalities by way of energy colonialism, reflecting global inequities where wealthy nations and entities as a whole exploit resources in poorer regions. And similarly, within countries, underserved communities face systemic barriers that increase their energy burden. And energy colonialism often targets regions with less political power, less affluence, and less economic development, similar to how energy burden disproportionately affects economically disadvantaged communities. And both of these concepts lead to environmental degradation and also lead to health consequences in these affected areas. Energy colonialism often results in ecological damage in regions where resources are extracted, while high energy burdens can lead to inadequate heating, cooling, and ventilation in homes, in residential homes, which really impacts residents' health, especially because we don't have federal mandates for indoor air quality. And so addressing both issues requires comprehensive policy interventions and advocacy. And solutions include, which we've talked about and we'll talk about, equitable resource distribution, investments in sustainable and affordable energy infrastructures, policies that promote the needs of affected communities, and leveraging federal dollars that are coming down, especially related to energy efficiency tax rebates like HOMES and HERA, Homeowner Managed Energy Savings, and High Efficiency Electric Home Rebate Act. And so understanding these links, it's really crucial for developing holistic strategies that both address global and local inequities for energy access and sustainability, and really highlights the need for a shift towards more equitable energy systems that consider the needs of all communities, no matter your socioeconomic background, but particularly those that have been historically marginalized and underserved. Next slide, please. And so particularly one of the key solutions to mitigate such disparities lies in the concept of building electrification, the process of converting fossil fuel-based appliances, systems, and infrastructures to using electricity in core functions of cooking, heating, and cooling in commercial and residential new buildings and existing buildings as well. And so at Sierra Club, we've broken building electrification into 5 key pillars, including equity, electric, efficient, grid interactive, and having intelligent control systems. And we believe having the equity portion, it centers environmental justice perspectives in every stage of the process. That includes the procedural dimension of it, the distributive dimension of it, and the representative aspect of it. Electric by way of exploring opportunities and benefits of electrifying fossil fuel processes, taking into account regional differences in technology available and policies available, including economic feasibility and just the nature of climate in a particular region, and efficient as it relates to advocating for the design and construction of efficient buildings, which emphasizes the need for existing structures to be retrofitted and designed more effectively to promote more sound efficiency, and then emphasizing the potential of grid interactivity because it plays a key role in grid stability and just maximizing consumer value as a whole, and ultimately having intelligent control systems to highlight the importance of smart controls and automation, and improving energy use and enhancing building comfort is a key part too. Next slide, please. And so the transition to an equitable clean energy future, particularly and reducing the reliance on traditional fossil fuels. Methane is a word, the keyword I like using, beyond methane RVA, for that reason, and avoiding the expansion of gas pipelines really calls for future forward strategies. And I like this word, future forward. It's a phrase that my colleague Tim Sawinski from Sierra Club Virginia chapter introduced me to a while back, for like several compelling reasons. Like one of them, it's pertaining to the alignment of our climate goals. Our nationwide and statewide climate goals are ambitious and imperative if we are to create a more sustainable future for us all. The IPCC has made it clear that we must drastically reduce carbon emissions, as we all know, to mitigate the worst effects of climate change. And so our continued reliance on fossil fuels, including natural gas, other things, it's incompatible fundamentally with these goals. And future forward strategies prioritize renewable energy sources and innovative technologies, which are essential to meet emission reduction goals. And this involves reimagining our energy infrastructure, moving away from gas pipelines, which represent a commitment to outdated technologies. And another key part of this is promoting economic and health benefits. And transitioning to a clean energy economy really offers a lot of benefits in these two areas. First, renewable energy resources, once established, are cheaper and more stable in pricing compared to fossil fuels, whose costs can fluctuate widely based on geopolitical conditions and the market, as we've seen with recent times. And this stability can be a significant economic boon. And chronic conditions like asthma are often exacerbated by pollution caused by fossil fuels, and 12% of childhood asthma cases can be attributed to gas stoves. And with regard to innovation and job creation, embracing future forward strategies really opens the door for innovation in clean technologies and consequently job creation. So the workforce component is very important. And the clean energy sector is poised for growth and offers a wide range of employment opportunities, which really promotes stability in the long run for our clean energy future. And fundamentally prioritizing the equitable part of this transition means ensuring that these jobs are accessible. So overall, what this topic of energy efficiency and building electrification promotes energy conservation, just making energy more affordable and accessible for all, especially lower income communities. Thank you.
Okay, I think I'm up. Can we go to the next slide, please? Awesome. So my name is Kevin Sanforini. I do tons of work with Beyond Methane RVA. And I'm going to talk to you people about gas utility economics. Kind of a wonky subject, but let's take it from a 10,000-foot view. I have a feeling everybody in this webinar is very knowledgeable about this, but I'm going to assume zero knowledge. So when we think about infrastructure projects and utility projects in particular, there's a funny quirk about them. And that's, to do anything useful with your utility, you must first have all of your infrastructure in place before you can start charging people money. And for that reason, we must charge or we must take out tons and tons of loans to provide something useful, which then gets paid back over time. Next slide, please. So a lot of this portion of the talk is going to be heavily focused on Richmond, but we're going to draw it together with some, national things. So Richmond's Department of Public Utilities owns Richmond Gas Works and runs Richmond Gas Works. And we basically looked at a bunch of data about our finances. And the more we looked at this stuff, the more we realized that the financial argument was a more compelling thing than the climate argument. And to sort of put a point on that, going back to the year, I believe, 1997, our gas utility has experienced roughly $760 million worth of investment. That doesn't directly correlate to debt, but we do have a very large amount of debt, roughly several $100 million. And more recently than that, our gas utility is issuing another about $110 million bond prospectus to expand. And we'll get to that in a moment. But next slide, please. So using data from the Energy Information Administration over that same time period, pretty simple. We've got, roughly, I think it's 30,000 new customers, and that's quite a lot for the Richmond area. Next slide, please. And with all those new customers, we were like, oh, that's kind of weird. Like, what's going on with this? So we basically scraped all of the permit data from Richmond, and then we mapped out where these permits were happening with the help of the University of Richmond Geospatial Analysis Lab. And that red circle right there is very approximately the borders of Richmond City. And then right around the year 2007, you can see that our gas infrastructure really explodes out into the surrounding counties. And one quirk of Richmond is that our surrounding counties and the city area, it's a very gradual change. Like there's very little distinction between the city and the counties. And what this means is we're running more and more pipes and adding more and more customers onto our service system. Next slide, please. So we've got all these new customers. We're spending hundreds of millions of dollars on this system. Surely we're selling more gas. Next slide. But we are not. Over the last 20 odd some years, we have sold exactly, almost exactly 0% more gas than we sold in former years. However, we have about 30,000 new customers. And if we invert that claim, next slide, please, you can look at it a different way, which is the per person or per capita consumption of gas is down quite a bit, about 37%. And I want to reiterate that all of these extra people that we've onboarded onto the system, they cost money to introduce to the system. So we started hammering away at this claim. And then finally, in March of 2023, next slide, please, we, had a moment of clarity where we're not the only people saying this. So in a local city council meeting, our Department of Public Utilities basically admitted the same thing. And this was actually the justification for one of our rate hikes, which is that people are consuming less gas, so we need to raise the price. And a quirk about municipally owned utilities, for those who are not familiar, is that your rates typically directly correlate to how much debt a utility holds. There's a bunch of fancy math functions which determine your rate, and it's directly tied to the amount of debt service you have. This is a little bit different for investor-owned utilities. Investor-owned utilities are generally granted the ability to make something like a 10% profit for those natural monopolies. So it's even worse for investor-owned utilities. Next slide, please. So I want you to file that away in the back of your mind for a second, and we're going to revisit the leak story. So in the per the Department of Transportation, the U.S. Department of Transportation, gas utilities across the entire nation are required to replace these things called leak-prone pipes. And there's not a super clear definition of what a leak-prone pipe is, but we definitely know it is cast iron, unprotected steel, things like that. And these pipes tend to be very, very old. And these pipes are also being replaced with plastic pipes. So with a Freedom of Information Act request, we figured out exactly how many miles of pipe Richmond has left to replace. It's 192 miles, and we have to replace by the year 2033. So next slide, please. And one thing that isn't great about this is that we're replacing all these pipes, but the question is out there of, do these pipes really mitigate leaks? And one thing we're trying to hammer home with our efforts at Beyond Methane RVA is that gas leaks, period. Like as long as you have gas service, you're going to have leaks. And this sort of goes back to what Nathan was saying earlier, which is like there are some super emitters that you can sort of mitigate, but the gist is that we need to be transitioning off the gas system to stop leaks. And to tie this back to finances, we're going to be spending hundreds of millions of dollars replacing these pipes, and we might not get a tangible benefit out of it. Next slide. So I want to tie this together with sort of the national story. This is, again, heavily focused on municipal utilities because that is what we know best. But there was a recent report for Philadelphia, and they mentioned that the cost to replace pipes is about $2.1 million per mile of pipe. I want to remind you that Richmond has about 192 miles of pipe to replace. And in Philadelphia, this would saddle customers with $8 billion worth of debt. Next slide, please. Similarly, in the entire state of Maryland, their cost is in the same ballpark, roughly $2 and some change million. And for the entire state, it would saddle their customers with $34 billion worth of debt. Now, why do we care about these large debt numbers? Next slide. And that's because when we're replacing pipes, it does not generate new revenue. If you're replacing a pipe to somebody's home or building that is already serviced by gas, you are not generating new revenue. So all your utility is taking on is liability. Next slide. And in the case of municipally owned utilities, since your rates as a customer are directly, derived from the amount of debt a utility holds, your rates go up. Next slide. And here's where we tie it all together. There's a really fancy, wonky term called a utility death spiral. It's really not blown out of proportion, but it is a silly term. There's several entry points to this, and Richmond is experiencing multiple between replacing pipes and the reduced consumption. But let's start with reducing consumption. So you have high rates, there's frustration, you have more efficient appliances, or in Richmond's case, we may have been onboarding people onto the gas system, which never would have paid back their infrastructure cost. And when the consumption is reduced, next slide, the utility loses revenue. That's pretty self-explanatory. Next slide. But then, because we've already taken out all of this debt to pay for the pipes in the ground and to pay for the new pipes that are replacing the old pipes and so on and so forth, rates have to increase. And this is to pay back debt service that we have already committed ourselves to. Next slide. And when we increase the rates, people get increasingly frustrated, they reduce their consumption, so on and so forth. And it becomes a vicious feedback loop, hence known as the utility death spiral. Next slide, please. And one thing we really need to call out as an organization is that as this consumption sort of reduces and dwindles, the people who are left behind on the gas system are what we like to call the rate burdened, and then there's also the late adopters. But the rate burdened are primarily people who do not have the financial latitude or do not have the autonomy over their own home or building to really change the appliances and physically get themselves off the gas system. So to some degree, they are required to consume gas, and this utility death spiral is going to shackle them to a lot of financial pain in doing so. And that's sort of the high level of gas utility finances. Next slide. I think we can answer some questions now. Thank you.
Thanks so much, Kevin, and thanks everyone. Yeah, appreciate it. Do we have all of us on camera? Great.
Kevin, I have maybe we can start there since you're with the last one up. I have a question for you because it sounds like what I was hearing was that in some ways the utilities are almost like perversely incentivized to build new infrastructure because they can justify taking out loans or bonds or whatever. So you get this kind of almost like it feels like a House of Cards type of thing happening. I don't know how to describe it, where these continued investments are sort of like mask the problems that were already there. And I don't know, can you just dive into that a little bit? Maybe just make sure we're understanding that.
Yeah, so there's maybe two angles to tackle this from. I want to start with the municipally owned one. So speaking anecdotally for Richmond, right, like we have this fairly compact city and it is saturated. Like you have all of the gas customers you're ever going to have in the city. And because, the bill is coming due to replace all of this aging infrastructure that's quite literally falling apart, like, where are you going to get that money from? And the sort of knee-jerk reaction from, I like to call them the infrastructure cult, is, well, like, let's keep expanding our infrastructure. And that gives us a little bit of runway because, you take out some loans and then you start getting new sources of revenue, and then you can take out more loans and pay back what you already have. And to some degree, this is a Ponzi scheme. This is what is talked about in the book Strong Towns a lot, although it's not, directly about gas infrastructure. And I'm fully convinced it's happening in Richmond. Things get a little bit more sinister or perverse for investor-owned utilities because they are guaranteed to some degree a return on investment, normally about 10%. So they are profiting from replacing these pipes in a lot of instances at the detriment of customers and energy burden and equity and all of that.
Thanks.
Does that answer your question?
Yeah,
Yes,
for sure.
thank you.
Yeah,
Thank you.
absolutely. Well, I think opening up to all the panelists, and maybe starting with Nathan. But Nathan, I mean, you said there were 3,356 gas leaks that you uncovered in Boston, and then David wants to know that there's, what's the threshold of these leaks that you discovered? Are these like the major leaks, and we're not counting, the tens of thousands of other small leaks? What kind of threshold were you using on that number? And then as a second part two of the question, what about all the other small leaks? And if they add up to that other 50%, are those ever pluggable?
Yeah, so I'll take the last question first, which is that highlighting that 7% of the leaks account for 50% of the lost gas. That is true, but that also means that 93% of the leaks, which may be tiny, also contribute 50% of the leaked gas. So we really can't ignore the aggregate effect of all the little leaks that add up. In the Boston study, we had a quite conservative threshold for what we called a leak. It had to be like half a part per million above the stable background methane level, which is a pretty high bar. So there's likely more than 3,356 leaks in Boston at the time that we did the study. But even our study had 3 times more leaks than what the utilities recorded. So yes, this is what we call a long tail distribution. There are many, many leaks, and the smaller you go, the more leaks you're going to find, down to the level of there's leaks in houses, which may be tiny in terms of greenhouse gas, but they have other nasty compounds in them which are bad for human health. So yes.
Thanks. I see, Kevin, it looks like you have your hand up. Go ahead.
Yeah, in the Q&A, Ken Dolsky asked, what was the cause of the drop in consumption in Richmond? I think there's a few things happening. So in Richmond in particular, we are continually expanding our infrastructure outward outside of the city bounds. And most recently, we're expanding into a fairly rural area called Goochland County. So there's a few things. We're onboarding customers who we believe probably never would have paid back effectively like what their infrastructure investment was. So if you look through the connection permits for a lot of the county connections, they're things for like just connecting a fireplace. And bear in mind that those are like tens of thousands of dollars to run the pipes to this person's building or house for something that's only going to be used regularly throughout the year. So that's one. Another one is Richmond, Virginia is a very mild climate. So it's very, conducive to run heat pumps here. I think they're probably becoming more popular. And then just generally speaking, higher efficiency appliances. And then the whole feedback loop of people being frustrated with their gas prices. And there's a very high level of frustration with Richmond's utilities in general. And I can see that contributing to the reduced consumption on a per capita basis.
Yeah. Heat pumps are becoming more popular in Virginia. I think they're in the top 10 states. I was just looking at the chart.
I mean,
Brian,
I was just going to say, through my work with the Public Utility Commission here, it's clear that while this whole conversation of fuel switching can be fraught in different places for political reasons, primarily, everyone agrees that energy efficiency is a good thing to do. So you have this like and the IRA has got money to help us get more efficient homes, et cetera. And even if you don't use the IRA money to electrify, you just use that money to make your home more efficient, you're going to be using less gas. So it just feels like, all the signs point to lower consumption per capita, and the consumption reduction doesn't reduce infrastructure costs at all. It has, infrastructure costs are going to go up because it's aging. So you have this weird situation where infrastructure costs are going to go up dramatically, consumption is going down. That can only lead to higher costs per capita, even without thinking about all the leak problems that we should be really concerned about as well. So yeah, makes sense. It makes sense to me. Thank you for that clarification.
Obviously, I had a quick question for Mary. Mary, you were talking a little bit about passing the cost being passed on to the consumer, and the utility doesn't have the utility doesn't usually pay that cost of the missing gas. Can you talk a little bit more about that?
It's quite common in the gas industry. And so as we talked about with new construction, they are getting a return on investment, but just in terms of what we're finding as being leaked, that is not something that has to be covered by the gas firms. And so of course everything has to get passed on to the consumer if that's really who's paying the bills. So I don't know if anybody else has something that they want to add to that. Nathan, I see you nodding your head.
Yeah, I just agree. You put it well.
Well, maybe related to that, and maybe this is a question for you, Lee. Okay, so we know these gas leaks are happening. And I think obviously the level of information about them is spotty, and it's not evenly distributed across the country, et cetera. You guys have done a lot of work in your area. But let's just say that we did know, we had good data about where all these leaks were. Who's responsible for fixing them? And are gas companies legally required to fix them? What did you learn about this in Richmond, and what do you think that the answer to that question would be?
Well, I don't know the legalities of it, but I believe that it's the Department of Public Utilities and the Richmond Gas Works. The problem is they're outsourcing all of their repairs to a third party. And so they are kicking the can to an outsourced repair company. And all they do is check off on the work for DPU. I see Kevin wants to add something.
Yeah, so when we FOIA'd the,
By the way, FOIA is a Freedom of Information Act. I just wanted to put that out there because I've been seeing that term there just to make everyone aware. Thanks. Sorry, Kevin.
Yep. So for those unaware, the Freedom of Information Act is just, generally speaking, a law that allows, constituents like you and me to request information from your government. And since our gas utility is owned and operated through our city government, they are subject to FOIA. So with that being said, we FOIA'd, the roughly 1,000 leaks or whatever, and we didn't have really granular information for each leak saying like, oh, this is 100% LEL, this is 50, this is 10, whatever. We had 3 grades, and these grades are defined by, I believe, the U.S. Department of Transportation. Somebody correct me if I'm wrong, but they're grade 1, grade 2, and grade 3. And grade 1 leaks are by and large required to be addressed immediately. Those are leaks which are extremely liable to explode and typically inside buildings. Grade 2 leaks are generally liable to ignite, but they're venting into the open air. So you might have a really severe leak that is in a street or something like that. And grade 3 leaks are really negligible. And each grade of those leaks has different repair requirements. Grade 2 has to be addressed within a certain amount of time that is escaping my brain right now. And grade 3 I didn't even think to look into because Richmond is predominantly grade 2 leaks. So that's not something, the grade 3 leak time repair is not something I'm well acquainted with.
Well, thanks for that. Those grades are helpful. I did want to ask, there was a question from Ken in the chat, and maybe this one is for you, McKenna. So Ken brings up a big issue with migrating to electric in EJ communities is the cost. How can we demonstrate to people who are paying so much for existing energy that the getting them off the gas lines and transitioning to electric is worth it?
I think one of the key things that, a compelling message for environmental justice communities, at least in the implementation portion of, energy efficiency and just electric technologies as a whole, is, the cost portion, as the question can alluded to. What's needed is a system of on-bill tariff financing, essentially, because I mentioned homes in HERA in an earlier question that Edward presented in the chat related to labor conditions for the workforce who will be carrying out and are carrying out improvements and integration into existing residential and commercial properties. But without the on-bill tariff financing, it's next to impossible for low to moderate income households to actually adopt these technologies. And while Homes in HERA is a monumental opportunity out of the Inflation Reduction Act, and if people didn't read my message earlier, HOMES refers to homeowner managed energy savings. HERA is high efficiency electric home rebate act. Essentially, in Virginia, both pots of funding, we're receiving $93 million in funds, essentially allocated for 80% AMI households to get up to $8,000, for example, for space heating, $840 for electric clothes dryer, thousands for windows, insulation, retrofitting, weatherization, things like that. But again, that's not enough. We know the cost of electric and energy efficient technologies that won't cover the full cost of it. And people don't have, $5,000, $10,000 extra to shell out. And so what needs to happen, incredible work that's being done by Verdant and other coalitions, a part of, in Virginia, at least I can speak from the Virginia point of view, is thinking about what a full-scale weatherization package looks like. So when the State Energy Office, Virginia Energy, submits their state plan to Department of Energy, SCEP, State and Community Energy Programs Office, by January 2025. They recently onboarded their program manager who is going to be supporting the stakeholder engagement process that a consultant will be leading as part of the stakeholder engagement group that will help inform the state energy plan. And so all this is something that will be and needs to be considered as part of this process of incorporating energy efficient and electric technologies for these specific households in general. But I agree, if we don't have that the bill writing component, then it's not going to be implemented. That's just a long short answer.
Yeah, I think that. No, thank you
for sure.
I wanted maybe this is a question for you, Dr. Phillips. I mean, you mentioned this in your presentation, but I just want to come back to this to put a fine a little emphasis on it. So we're seeing these leaks happen everywhere. And although, your studies are mostly focused on the urban environments, you mentioned some of these studies that were looking at the leaks that were happening all across the supply chain. So, or the chain from wellhead to home. But just give us a little bit of context on why this matters. Again, I just want to come back to that for a minute, because these leaks, when you add up the ones that are happening from wellhead all the way to our homes, and of course you mentioned different studies that showed slightly different, interpretations of the scale of those leaks, but give us a kind of just a rough idea about why those leaks really change the picture in terms of what our gas use is doing to the environment. I mean, so I just want to maybe just hit that one more time, because it's really such an important point.
Yeah, so excellent point. And it's kind of pick your poison with the gas leaks. They kill trees, they waste money, they damage the climate, they damage the air quality. So all of these problems are intersecting. They're playing out on from the local, where there could be an explosion, to the global, where there's a climate change, to the air pollution, which is a regional city level problem. So there are the environmental justice dimensions, there's the climate justice dimensions. It really covers the gamut. And I think that the thing that struck me when we published our Boston study was that it wasn't that the problem wasn't known. The problem has been known for decades. It's just that the public didn't know. The regulators knew, the gas companies knew, it's been known for a long time. And so I think that like this gathering here of experts and the importance of networking like this and sharing information, I've seen how the making public of this information really has impact. So yeah, I'm appreciative of that aspect. Thanks.
Thank you. Thank you.
Would you mind if I just
Yep.
chime in? So there's some
Please.
great opportunities happening. I mentioned the Beyond Gas program that's up in Washington, D.C. right now, and they actually have an ordinance, and they're going block by, well, their intention is to go block by block and electrify entire neighborhoods because they are leaking so severely that it's cheaper to electrify everybody for free, and you don't have to worry about funding from the IRA or anything. I mean, just have the city council pass an ordinance and go block by block. Cities and localities can get reimbursed directly from the federal government, and it's just a faster way to do this. The second thing is our Office of Sustainability, with the help of Mary Finley Brook, Dr. Mary Finley Brook, is looking into geothermal and actually replacing our sieves that are in the middle of our road. So a lot of exciting opportunities. We just need bold leadership and the political will to carry it out.
That's great. Yeah, maybe that's a good segue to this geothermal topic because, you know, we have seen, I think it's Vermont Gas that's been looking into some of these ideas where they either use some of their existing pipes or use their know-how at least about underground pipes to do geothermal systems rather than gas systems. I mean, what's the, I don't know who to ask this question to. I know Dr. Phillips has looked at that a little bit, but what would you say about that? Is that a realistic thing to be thinking of where the gas companies, these gas utilities may have a role in our future that isn't just about dismantling them, but it's maybe using their know-how in a different way?
Well, you mentioned my name, so I'll take a quick stab at it. And it's a really excellent question because the tapping into the thermal resource right under our feet is a kind of physical democracy because we're harvesting the energy right around us. It's also resilient because it's right there, it's local. We need the electricity to move it around, but we're really anchoring our energy system right around our homes and our neighborhoods. The question I have is that physical democracy, that potential, can it be done well with an investor-owned utility where wealth is concentrated and sent into distant areas? And that, to me, it makes me really have some caution when I see good things that investor-owned utilities are doing, like Eversource here in Massachusetts is doing the first ever network geothermal project. That's a really good thing. Is that the best way to go? I think we really need to think about the utility business models, public ownership, private ownership, worker-owned companies. So I really appreciate Kevin's coverage. And also, Philadelphia is a municipal gas system. They're not doing really well at all. So I think, and this Dr. Finley Brook mentioned some of these same issues, that just because there's a publicly owned utility doesn't mean they can't be captured just as bad as a investor-owned utility. So really, really excellent questions for us all to consider.
Thanks for that. I think maybe for one last question, unless Brian has something burning after this, but for everyone, we always like to leave folks with practical advice or something they can do to help improve the situation. So maybe I'll ask each of you to leave us with a practical tip. I'll just say somebody in the chat was asking about what's the lowest cost methane reader I can get. But Dr. Finley Brook, maybe starting with you, what's a practical piece of advice for people to help solve this problem of gas leaks and help take this matter into their own hands?
Well, I'm going to go with the education role. I mean, we really, as was just said, like regulators have known about this. The problem with methane gas a decade ago, we were saying, you know, it isn't a bridge fuel, and these arguments keep coming back at us. So people really do need to get some basic information, find out what is happening in their own city, find out what is happening in whatever institutions they're involved in, whatever their job is. I'm just going to really promote getting educated about where your energy comes from and looking at the full life cycle, right? Not just looking at, oh, I think I plug it into the wall and therefore I must be okay. So I'm gonna promote education.
And on a note for that, could you put a link to? I believe I haven't had a chance to read it yet, but you wrote a book on the topic, so we'd love to plug that to
It's
folks.
still forthcoming. It's still
Okay.
forthcoming.
Oh, it's on its way. Okay. Well, maybe a website where folks can track it. Lee, why don't we go to you next?
Gosh, I say get out from behind your computer and get involved. Meet your city council members, meet your neighbors, talk about issues that are important to you. It doesn't have to be methane, but I think for this group it does. But there are many ways that you can move the needle on the climate crisis, on democracy, but you have to get out there and show up. And it's hard. I'm a extroverted introvert, so I'm going to go like into my cave when I'm done here and just lick my wounds, but it's hard. Public speaking is horrible. I was in a flop sweat 2 hours ago, but you got to do it, because if you don't, nobody else might.
That's so true. I love that. Thanks. Dr. Nathan Phillips.
Yeah, a phrase that I have just really been thinking a lot about recently is energy democracy, and just that the scale of our problems with climate can seem so enormous, but we have opportunities to work in our communities locally and push for a say in our energy system, and if that's gas and how we fix it, how those resources are delivered. It's our money that is paying for this, and I think that's an opportunity to really build our movement for change as energy democracy.
I think for me personally, I would just urge viewers of this webinar to really understand the fundamental definition of environmental justice, as Dr. Robert Bullard has focused his community engagement, landfill, and just general environmental justice work since the 70s on, get an idea of the Hermes principles that are focused on, intersections of energy justice-oriented practices in general, and, think about, and I say this to everyone, even if it's not like energy related, please write down your vision of a sustainable future and the practical common sense ways and approaches that your local community or nationwide community, whatever, can get there, because having that mental framework really supports your work and just knowledge and coalition building from within your mind and from actual communities. That's what I recommend.
Thank you. Thanks, McKenna. Great. And Kevin.
Oh, there's so many suggestions. I think my biggest one is to be inquisitive and persistent. I'm a utility professional, but I'm a software engineer. I work on code for power grids. I am not a finance person. I asked questions, and when I was told to shut up, I kept asking questions, and I kept asking questions. And we were, as an organization, consistently shrugged off by our Department of Public Utilities in Richmond. And now look where we are. We got a city ordinance passed, and we have oversight incoming over our utilities. So persistence and inquisitiveness, I don't know if that's a word, are sort of key to this, because by and large, the information is out there in one form or another. Energy Information Agency posts tons of information. There's likely Public Utility Commission filings for your local utility. It's just not in a appetizing format. You probably won't have news reports on the pipe that's replaced in such and such a location. Or there were certainly not news reports of the $110 million bond prospectus for Richmond's public utilities. All of this information is out there. And if you keep asking questions and keep pressing on your elected and appointed officials to do the right thing, something good will come of it.
Well, I love that. Thank you, Kevin. And I'd just like to reinforce that note you made in your presentation about a lot of us are coming at this from the climate perspective and thinking about it as a, climate problem. And of course it is. It is also a health problem. But as you point out, it's also and as McKenna it's also a justice problem, but it's also a financial problem. It's a simple economic problem that a lot of these utilities seem to be facing, that it doesn't look like a very rosy future if we just continue to do business as usual. So I love the fact that we're kind of bringing that other dimension to the conversation there and asking questions. I love that. I do have one last question for us. Sorry, this might be a little bit more self-centered, but for those, I get this sort of narrative that develops from this conversation about these, particularly on the East Coast, this really aging system. Do you have anything to say about what it looks like in other parts of the country? I mean, do you think it's vastly different, or do you think it's just a slightly different version of the story that you're uncovering there on the East Coast?
I'd like to take a stab at this.
I don't know who wants to tackle that.
I'll tackle it from a really high level, and then I'd like to pass it over to, I believe it was Nathan that just spoke. So one of the people who works with us in Beyond Methane RVA basically did a visualization like I had on my slides for the finances of Richmond Gas Works for every gas utility that reports themselves to the Energy Information Administration. There's something called Form 176 from the Energy Information Administration that reports tons of data, including the number of customers, industrial customers, profits, costs, things like that. And when you visualize all of that data, it's quite apparent that most gas utilities across the country are facing financial hardship, not just Richmond's. And that data is out there in the open for anybody to look at. Great. Nathan, do you want to add anything to that?
I think that was a great last word by Kevin, so I'm going to just second what you just said.
All right. Well, Joe, should we wrap up here? I mean, this has been fascinating. I want to thank all of you, our panelists here, for two things. One, for the amazing work that you're doing, all of you individually. I mean, I'm inspired by what you're doing. And also want to thank you again for being guests with us today and leveraging your experience and your knowledge to help all of us get smarter about this. So thank you all for helping us today on this important topic.
Yeah, +1 on that. Huge thanks to everybody. We'll send out slides and recording shortly. And as we like to say, good luck on your electrification projects, and reach out if you have any questions. But thanks to everybody.
Thank you very much.